today, notice that the chapter name is Chapter 5. And we just took a test on Chapter 5. However, this is Chapter 5 from another book. And what we're going to do is going to be our introduction into trigonometry, and we're going to just be talking about angles today. So this time we're going to be graphing our angles on a coordinate plane. Now, we're used to seeing acute angles, right angles, obtuse angles, but what we're going to be seeing in this chapter are angles that are going to be greater than, say, an obtuse angle. We're going to be seeing angles that are greater than 360. We're going to also be seeing angles that are less than 0. We're going to be seeing negative angles. And that's all going to be depending on the direction that you draw your angle. So our angles that we're going to be drawing are going to be on a coordinate plane. So this could be my x-axis here. And this is my y-axis. And for example, this could look like it's probably around, if this is a right angle here, this is 90 degrees up here. Over here where it starts is 0 degrees. If I go around a half a circle, this is 180 degrees. If I go another 90 degrees, this would be 270. And then if I make a full circle, I'm back at 360. So we could say that this one right here that's drawn, this red one, this looks to be about 30 degrees. Now, also remember back when you learned about the coordinate plane, remember that this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. It's going to be important that you can understand which quadrant your angles are going to end up in. Now, notice this red arrow here. This is going to indicate that the direction that you're measuring your angle. When you draw your angle and you measure it counterclockwise, the arrow would show up here, your angle measure is going to be positive. If I were to draw an angle counterclockwise, starting here at 0, and let's say it came down here, coming to this point, this would also be a negative 90 degree angle. So over here at this point, this is positive 270 if I go clockwise, counterclockwise, but if I go clockwise, it's negative. This one over here would be negative 180. Up here would be negative 270 and the positive 90. And then same thing here, it could be a negative 360. Now, the parts of this angle, the starting point here, this is the initial side where you start, and the side where you end up is called the terminal side. Now let me come on over here. So notice here they've drawn a negative angle. So this one over here could be like a negative 30 degrees. If you, again, went in the opposite direction, it could be a negative 90. So if you think about the quadrants, just add another one here. In quadrant 1, your angle measures are going to be from 1 degree to 89 degrees. In quadrant 2, the angle measures will be from 91 to 179. Because again, remember up here is 90, 180, 270. In quadrant 3, the angle measures are going to be from 181 degrees to 269. And then lastly, in quadrant 4, they'll be from 271 up to 359. Because again, this is our initial side and where we could end up if it's a full circle. So for example, if I wanted to draw a 135-degree angle, what I would do is start here on my initial side, and then I would go 90 degrees, and then probably about another 45, draw my terminal side, and then show the arrow in here. And this would look like it's approximately 135 degrees. Let's say I wanted to draw a 240-degree angle. So I would start here at 0, go to 90, 180, and then I need to go a little bit more to get to my 240. From 180, I'm going to go another 60 degrees. And you can say that you're going to end up about here. And you could say that this looks like it's around 240. Again, we're approximating this. We're not going to be using protractors or anything to measure these angles. Just know where it should end up and then approximate it. Figure halfway in between that would have been 45. So again, my angle measure there looks reasonable. Let's say I wanted to graph a 330-degree angle. So I'd start here at 0, hit 90, hit 180, hit 270, and again, go 60 more, and I could say this would be around a 330-degree angle. Now, we'll also be graphing angles that are greater than 360. So let's say I wanted to graph a 720-degree angle. I'm going to swirl around. I would go 90, 180, 270, 360, and then to get to 720, I got to spin around again. And this would be a 720-degree angle. So we'll swirl around multiple times. But just remember these major cutoffs here. This is 90, 180, 270, 360. So a coterminal angle is going to have the same initial side and terminal side. It's either going to have more or less rotations around the circle. So to find a coterminal angle, we're either going to add or subtract 360 degrees. Now, if it asks for a positive coterminal angle, it needs to be a positive answer. If it says to give a negative coterminal angle, it must be negative. So for example, let's say we take the 30-degree angle that I initially had drawn before. Let me draw my coordinate plane here. And again, we've got our 0, our 90, our 180, our 270, and our 360. So let's say I initially draw a 30-degree angle. And I want you to find me one positive coterminal angle and one negative coterminal angle. All we need to do is take that 30 degrees to get to the positive coterminal. I'm going to add 360, and I'm going to graph a 390-degree angle. To get to a negative coterminal angle, I'm going to take the 30, and I'm going to subtract 360. Remember, for the coterminal angles, it's going to start out at the same initial side and end up on the same terminal. So this is my initial side here, and this is my terminal side here. So if I wanted to graph the blue one, the positive coterminal, I start here. I'm going to go around 360 and then up to the 30. This would be a 390-degree angle. Remember, to graph a negative angle, we're going to start and go clockwise. So I'm going to start here, same initial side, but this time I end up on this back side of the terminal. And this would be a negative 330. These are coterminal angles, both to the 30-degree angle that I initially drew. Now, sometimes the angle that's going to be given to you is going to be really large. And to get to a negative coterminal angle, you may have to subtract 360 more than once. So if it asks for a negative coterminal angle, once you do the subtracting 360, you're going to have to maybe do it more than once. So let me show you an example. So let's say I ask you to give me a negative and a positive coterminal angle to 750. So if I wanted a positive, I could do the same thing I just did. I could do 750 plus 360, and I can get a positive coterminal angle this way. It's going to be really big, but that's okay. This would be a positive coterminal angle. Remember, there is an infinite number of coterminal angles because you can keep adding or subtracting 360 as many times as you want. Now, watch what happens here. When I try to get the negative coterminal angle, if I take the 750 and I subtract 360, 750 minus 360 is going to give me positive 390. This could have been an answer for a positive coterminal. I'm still not at negative. So both of these are still positive. Coterminal to the original 750. To get to the negative coterminal, I got to try to subtract 360 again. Notice I'm still not there. This is still positive. So I need to subtract it one more time to finally get to the negative coterminal. So this would be the negative coterminal. So technically, any of these, whether I just added 360 to the original, when I subtracted 360 because it was super large, my number is still positive. And then same thing here. So any of the three that I just boxed in blue could be acceptable positive coterminal angles to the original 750. So for example, if I graph the original 750, I'm going to swirl around. So let's say I'll do the original one here in black. So if I go around a full circle, that's 360. If I go around again, I'm up to 720. To get to 750, I got to go another 30 degrees. So I could stop about right there. Again, make sure you include the arrow so you know which way you are going. Positive goes counterclockwise. Now, if I were to graph the 390-degree angle, let's say I'm doing this one. So this one was in black is 750. If I do the 390 in red, I could go around one full circle is 360, and then 30 more degrees gets me to 390. Notice they're both starting on the same initial side and both ending up on the same terminal side. If I were to graph the negative one now, so the negative 330, I could do that in blue. Again, we start here, but we go clockwise. So 90, 180, 270, and then a little bit more and end up at the negative 330. So they're all ending up on that same terminal side. We just have to swirl around more than once. They're all coterminal angles. So this slide says to find two coterminal angles, one negative, one positive. So I have 908. So what I could do here, if I wanted to get to a positive coterminal angle, I could just add 360 to it, and I get 1268. This could be a positive one. However, I could also subtract 360 because that's not going to get me to a negative number right away. So 908, if I subtract 360, this gives me 548. This is another positive coterminal. Even if I subtract another 360, I'm still not at negative. So I got to keep going. This is still positive. Finally, when I do it one more time, I finally get to a negative coterminal. So any of these would have been acceptable for the positives. And then finally, the negative coterminal would have been the negative 172. So all we're doing is adding and subtracting 360 to get to coterminal angles. Again, there's an infinite number because I can keep adding and subtracting 360 an infinite number of times. Let's try the next one. It's starting out as a negative 75. I still want a positive and a negative. So if I go ahead and find the positive one first, I take negative 75, and I'm going to add 360. I get positive 285. This is my positive coterminal. And then now to get to the negative, take negative 75, subtract 360, and I get negative 435. And this would be your negative coterminal angle. Then number 3, same thing. It's starting out as negative. Still to get a negative, I'm subtracting 360. This will give me negative 563. And to get to the positive, add 360 to the negative 203, and it gives me positive 157. Same thing for the 699. This one, if I don't want to have to add and then add 360 again, I could just do the subtraction, and that'll give me both positive and negative. So if I do 699, subtract the 360, this gives me 339. This could be my positive answer. And then subtract 360 to get to the negative. And that would give me negative 21. And these are all degrees. Everything we're doing right now is in degrees. Pretty good there. Okay, so when we're talking about these angle measures, when we did this in geometry, we probably only just talked about, usually, sometimes we were rounding to the tenths place. However, we can get a more precise angle measure by measuring it in degrees, minutes, and seconds. So like, for example, if you're running a race, and let's say you're running a mile, you're not going to want to just say, oh, I ran the mile in 6 minutes. You want a more precise measurement of how long it took you to run that race. Or if it's a marathon, you're not going to want to say, I ran it in 2 hours. You might want to say, I want to show that I've got a super fast time. I ran it in 1 hour, 20 minutes, and 49 seconds. You would bring it down to the second. Same thing here with the degrees. We can get a more precise angle measure by measuring it in degrees, minutes, and seconds. So we're going to be converting between degrees, minutes, and seconds. That's what the DMS says. And we're going to convert that to a decimal degree. And then we're also going to convert the other way and go from a decimal to degree to degrees, minutes, and seconds. So we're going to go both ways and convert it back and forth. Now, again, what you can do is think of it like time. Like 30 minutes is like half an hour. So if you were to turn 2.5 hours into a decimal degree, like 2 hours, 30 minutes, that would become 2.5. Does that make sense? You're dividing it by 60. And that's what we're doing here. So we're going to take the minutes, divide it by 60 divide the seconds by 3,600, which is 60 times 60. But when we go the other way, we're going to multiply. So let's try some examples. Again, the notation is going to have like the little quotation marks when you see it. Now, some of the calculators have a button that says DMS. Sometimes it's just easier to do the divide by 60 because you got to put in the quotations and stuff. So sometimes using that app that converts it takes more button pushing than it does just to divide by 60 or 3,600. So let's try some examples. So this first example, this is given to us in degrees, minutes, and seconds. So 74, this is the degree. 8, these are the minutes. And then the 14 with the quotation, these are the seconds. So they want us to convert this into a decimal degree. So the way that we're going to do that is the decimal portion, this is the whole number that's going to go in front of the decimal point. So we're going to do 74 plus, and then you're probably going to need to use parentheses if you want to do this continuous in your calculator. We're going to, if you can enter it as a fraction, wonderful. If not, you're going to do the division sign. So we're going to do 80 over 60 plus 14 over 3,600. So again, if you don't have the option to put it in as a fraction, you can use division, but use parentheses. Because remember, this is 60 times 60, the 3,600. Once you do this, you should be getting 74.137 degrees. So this is converting from degrees, minutes, and seconds into a decimal degree. Oh, and we're going to do this on the ones down in the bottom. But let's say we wanted to convert this back to the original problem. So what we would do here to convert it back, you're going to leave the degree alone. So it would be 74 degrees. But then I'm going to take the decimal portion. This 137, I'm going to multiply it by 60. So I would take 0.137 times it by 60. So 0.137 times 60. And you should be getting 8.22. What we do is the whole number now becomes the minutes. Then I take the decimal portion, the 0.22, and multiply it by 60 again. So 0.22 times 60, and that gives me 13.2. So this was a rounded answer. So that's why when we go to do this, we would get 74 degrees, 8 minutes, and 13 seconds, because this 14, what it was originally was rounded. Now, in the homework tonight, the PDF, they're going to just tell you to round it to the whole number. I'm going to double check to see if we're going to round our answers to the tens place. But just know tonight when you do your homework, just round it to the whole number. Let's try the next one. So again, the 165, this is going to be the degree or the whole number in front of the decimal. Then I'm going to take the minutes, divide it by 60, take the seconds, divide it by 3,600. And then once you do this on your calculator, you should be getting 165.4 165.853 is 165.8525. I rounded to 3 decimal places, and we got that. So again, just read what they're expecting you to round to on the homework. All right, so now we're going the other way. This is now in decimal degree. We need to convert it to degrees, minutes, seconds. So again, leave the whole number here, the number in front of the decimal point alone. That becomes your degrees. So 34 degrees. Then I'm going to take the decimal portion. I'm going to multiply it by 60. So 0.817 times 60, and you get 49.02. This portion, the whole number, these are now the minutes. And then now take the 0.02, multiply it by 60, which is going to give us our seconds now. And I get 1.2. Now, in the homework, they're going to probably want you to leave the answer as 34 degrees, 49 minutes, and 1 second. I will specify what you're going to be doing when you're doing the problems. I'll double check if we're going to round to the nearest whole number or if we're going to do the tenths place. Let's try the next one. Same thing. 59 becomes the degree. Take the decimal portion, the 0.08754. Multiply this by 60. Once you do this, you get 5.2524. Again, take this. This becomes the minutes. And then now take the decimal portion. I think that should have been a 4. So this is a 4 here. So this is what I'm now going to multiply by 60. And you get 15.144. And again, on the homework tonight, you're just going to put it in as 59 degrees, 5 minutes, and 144 seconds when you're checking your homework. But I believe we're going to leave this for the seconds. So, and I will clarify this, 59 degrees, 5 minutes, 15 point, and again, I wrote the wrong thing here. This should have been 15 here. 15 seconds. But again, if we do not round, we're going to go ahead and leave the whole thing. But I will clarify if we're rounding. In the homework tonight, we're rounding to the nearest degree and the nearest second. Make them all whole numbers.